The last part of the business with the expression microarray script is to put all illustrations in the right order. When you run GEO2R online, then the results and the figures appear at the end all in one time, and therefore you do not learn whether those figures are really necessary or helpful or useful for the understanding of the order of events in your script. But when you run the script yourself, then the business is completely different. The figures, when they're used in the right place, they help you to make your choices. So it is a part of the diagnostics of the data and also the necessary part of the results, how you show them to others. First things first, you run libraries. You need those four, you don't need UMAP. Then you run those lines which are exactly as in GEO2R, simply to get the data. Then the first illustrations appear, histogram. When histogram is so the scale is small and you clearly see two peaks, and this is a sign of the log transform data. You don't have to do it again, otherwise you have to run this line number 20. When you do a box plot, you simply compare samples between one another, and if they are not very much different, it means that the series is good, and if they are not exactly the same, then it means that quantile normalization is required, and so you run line 22. Then you have to make a sample table, as I explained before. So this will be a sample table with the simple parameters like cell type, age, batch, and the complex parameter, which is the combination of cell and age. That's the groups. And you can use one of those columns to make your colors. The trick is you declare as numeric as factor and then any column in the sample table. And what comes out is this simple integers 3, 1, 4, 2 for each of the groups. And now you can use those colors to plot MDS. It is the replacement of UMAP used by NCBI GEO. In this particular case, you use colors to stress out which are groups here: wild type young, LNK old, wild type old, and you see them well separated by first component. First of all, young between old, that's the biggest difference, and much smaller difference is expected for wild type and LNK. Note that plot MDS operates in two modes. If you use the gene selection common, then it will be PCA plot. If you choose pairwise over here, then it will be so-called PCO-A, which is also named sometimes MDS, and MDS stands for multidimensional scaling. You also can manipulate with labels. So here I call row names in samples, but if you don't specify what you use, then it will be simply column names, which in this particular case is not very informative. Another option is you use a dot instead. Let me see. Yes, here is a comma. Then it will be only dot. And so there is a flexibility in a way how you present your data. Then we run a design. Here, be flexible, select how you like it. You can do groups or cells plus age. It all matters. Depending on what you choose, your list of differential expressed genes will be different. Then you remove skip missing values. It's a line from the GEO2R script. You can keep it. You cannot spoil your script by this line. Now you do a fit. After you did the fit, you can plot assay. This is a dispersion plot, which simply tells you that if there is no bias in a dispersion across the average expression, so this is a shape of the oval or sausage, that's okay. Not too disturbed anywhere, that's okay. For the rest you can talk to statisticians. They will probably tell you about homoscedasticity and heteroscedasticity. That's the effects in dispersions. And if this shape is far too strange and disturbed, then you better use womb. So you go back to options and then use this parameter apply lemma precision weights womb. That's recommended for difficult dispersion patterns. Again, we learn here that illustration put in the right place is also important for you to make proper decisions. And since our dispersion is okay, we continue without womb. We define contrasts, we do a fit, and you can also run a fit 2 in a plot assay. It doesn't change. Then we come to the top table and do a subset for columns we want, and we select tops as we want, all without illustrations so far. Now we have to annotate because this set is not annotated, and then we do it only once. Because either annotation this way or biomarked way, it doesn't matter, you need only one. Back to our visuals. Now we can plot this distribution of p-values, which is purely technical. That's not a part of biological story. You can skip it. You can also skip a Venn diagram, which is not a part of biology. It looks strange and it's not in the right place. QQ-plot is again made by statisticians for statisticians, nothing of biology. Now we do a volcano plot as prescribed by GEO2R. It's not the most impressive plot. You can change a little. For instance, these symbols, these pluses can be replaced by something else. Out of simple plots, I prefer combination of doing plot points and text. So out of top table you do the plot of two columns, log FC and adjusted p-values, slightly transformed. then points out of top table. So in red is significant. And then I add the text derived from the merged table, and I choose for top 10 genes with the lowest adjusted p-value. You can choose also fold change or more genes or less genes, that's up to you. And this is the plot constructed out of data you have and the plot function you have. I think it's not bad at all. Alright, now plotmd is another way of showing differentially expressed genes. Names are missing, but you can find a way to add them in the way I use it for volcano plot. And now there is a bunch of illustrations at the end. Some of them are pretty good. For instance, if you run a boxplot, which is a boxplot, then you place it on the top of the script in a place where you really need it, not here. So here it is far too late. And in order to make it nicer, you can add the scale, and then add the legend. Now it is nicer. So it's also a trick which you can do yourself. Plotting densities is a plotting histogram. Again, it belongs to the top of the script, not here. Otherwise, it is a good replacement of the histogram. And plotters say what they add, we used it already before. So it is okay, it is good and important for diagnostics of the data, but it has to be much earlier in the script. That's all what you can use. Well, you can use a lot more, for instance, heat map and so on, but this is the minimum which is useful and necessary to describe what you got.